to India's first animated live tuition. Hello everyone, here we are with a new brand episode of 90 Plus again. So are you all ready to fly with the 90 Plus? Yeah, I can see those beautiful smiles. Very good. So can you give me a heart shape? I'm bored with the thumbs up. So you can give me the heart shape instead of thumbs ups so that we can start the chapter. Will you give me the heart shapes? Yes, very good. Thank you so much. Thank you so much. So how are you doing? How are you, ma'am? I'm doing great. I'm doing great. So how are you all doing? Fine, right? Yes, I hope you all are doing great with the studies and all the environment. Doing well. Take me to what? Alright. I'm doing great. How are you, ma'am? I'm also doing good. Going good. Yes, so are you all ready to begin the session actually? Are you all prepared or ready with the equipment, the book, the textbook, the notebook, especially the pen? We have to write it, right? The pen, the highlighter. Are you all ready with that? Someone is getting lipstick from there, right? I didn't mean that ready up, but with the equipment that we have to study. So, are you all ready? Definitely yes, ma'am. Please begin the session. So, in the previous session, I had told you we'll discuss the questions that we had taken in the exam, right? So that we are going to discuss those questions and we'll really begin the session, okay? So, we'll move towards the questions. We have already attended the exam, right? So, you know all these answers. Just you have to answer me by using your fingers, okay? Let me check how many of you remember this actually. So, you have to represent the answer by using your fingers. So here we go, the first question. The phase change of a matter from liquid state to gaseous state is known as what? It's known as what? Liquid. Let me change the color of the pen. Here we go, the green. Liquid to gas. Liquid to gas. What is it? Is it sublimation or condensation? Second answer. 4, ma'am, can you see? Are you blind? So, it's vaporization. Very good. So, you remember what is vaporization, right? Vaporization, evaporation, you must know it. We have already detailed discussed about that. Very good. Moving forward to the next question. What is the term used to describe the phase change as a liquid becomes solid? Liquid becomes solid. What's the answer? What's the answer? Quick. Very good. I want to see everyone's hand. Someone is like, I don't have fingers, ma'am. I will not show it. Is it like that? No, right? Yes. It is the third option, freezing. Freezing. Very good. And the next question. Which of these choices will not change the state of matter? Definitely, it's the second option. When we crush a crystal, it will break, right? It will not change the state of matter. The crystal will be in the solid state. It cannot be a liquid state when we crush it, right? So it will remain as the solid state. So second option is the correct answer. Very good. Now, the fourth one. In which phenomenon water changes into water vapor below its boiling point? Is it boiling? Is it boiling? Yes or no? Is it boiling or not? Nod your head if no. Nod your head. No, it is not boiling, it is evaporation. It is not boiling, it is exactly the evaporation. I'm so happy you remember everything. Very good. So here we go, the next one. The process involved the change of state of matter from gas to liquid. Gas to liquid is called as what? Gas to liquid. What is it? Very good. It is nothing but condensation. Condensation is nothing but this one. And also I have shown this image, right? You took a screenshot and written in your notebook. Am I right? Have you written this in your notebook or just took a screenshot and left it like that? Is it like that? Can you show me your notebook? Can you show me your notebook? With this diagram? Can you show me? Let me check how many of you have really written it. I have told you to take a screenshot of this image, but let me check how many of you have written it. Show me notebook, show me notebook. Everyone. Yes, I can see those notebooks. Someone is like, ma'am, I don't even have a notebook. So how can I write this diagram, ma'am? Is it like that? Everyone has the notebook, right? Ma'am, I forget, sorry. So okay. So after the class, you have to write this in your notebook. Okay, right after the class, you are going to write it. Okay. Yes. Is there any doubt regarding this picture? Is anyone have any doubt regarding this picture? We have the hand raised over there. Is there a doubt or raise a hand to answer anything? No. Let's call them, sir.
Niranjan.
Niranjan. Yes, Niranjan.
Ma'am, no doubt, ma'am.
No doubt. All right. So Daniel, why did you raise your hand? Is there a doubt?
Yes, teacher. Teacher, I don't know what this is. Sublimation.
Sublimation, we have detailedly explained that, right? The state of conversion of matter from solid state directly into gaseous state. This is solid, right? This is solid and gas. So directly from solid state to gaseous state without passing into liquid state is called as sublimation. Okay, solid to gas. Solid to gas is called as sublimation, and just opposite to the sublimation is deposition. Gas to solid. Directly gas from solid is deposition. Okay.
Okay.
Yes. And one more was there, sir. Who was that? Sanjit. Yes, Sanjit.
Hi, ma'am.
Hello.
How are you, ma'am?
I'm doing good. Thanks for asking. So, how are you doing?
The last session I was not there. I was not finished by the last session.
Oh, you were absent in the last session?
Yes, ma'am. For chemistry session was absent.
Okay, that's totally fine. We have a YouTube live over there. We have conducted a YouTube live in the YouTube, so you can just go and watch over there. Okay? Will you do that? Promise me, you will watch it.
I'll watch it, ma'am.
All right. Thank you. Ma'am, do we have to draw this? What is there to draw? Some boxes and some molecules, right? Some particles. Very easy, right? You have to draw it. Yes, you have to. Someone is like, I'm bad at drawing, ma'am. How can I draw this beaker? It's very simple, right? You can just write it or draw it. It's very simple. So moving towards today's session, okay? Today's portion. So what exactly are we going to study today? The effect of change of temperature. We are going to learn how does this temperature affects the change of state of matter. Okay, you have to pay 100% attention during the entire class. Okay, don't even blink. Okay, eventually you will blink. No worries, that also is normal. Okay, no worries. So you have to pay your 100% attention. Okay, I want your 100% attention during the class. So here we go with the portion. Effect of change of temperature. Effect of change of temperature. How does this temperature? Chemical formula of potassium permanganate. Someone asked this question in the last class too. Chris, it is KMnO4. KMnO4. Okay, potassium permanganate is KMnO4. Now, effect of change of temperature. Now we are going to learn how this temperature is going to affect the change of state of matter from solid to liquid or liquid to gas. How does this temperature affects? We are going to learn it. We already know those things, right? Yes, we already studied this, but we are going to study a bit detail. Okay, so can we have the animation, sir? The first one. As we know, as the temperature increases, we can change the state of matter, yes sir, from solid to liquid to gas. Am I right? Am I right or wrong? Yes, sir. I don't have the blank sir. Wait for a second, okay, wait for a second, and the animation is right over here. Here we go. So, can you just move it? Okay, I want to see the animation. Say, Jackie sir.
Yes.
More bit.
Okay.
Alright, so here we go with the animation. So just play. So here we have the ice, right? Ice is an example for solid, and when we heated them, it was all sudden, right? So when we heated the ice, it turned into liquid and suddenly into the gaseous state, into the steam, right? So temperature do affect the change of state of matter. When the temperature increased, ice converted into water and then water converted into steam. That means our temperature is affecting the change of state of matter. Okay, we already know these things, ma'am. Why are you showing this animation again and again? So let's remove it. Alright, so we know we can convert. Let me change the color of the pen. The green is not good on the slide, so let's pick the yellow. So we can convert solid into liquid into gas. When we raise the temperature, we can just change the solid into gas, to the liquid, and liquid into the gas. We already know this. Now what about the particles inside these things? Okay, generally we talked about that the temperature. When we increase the temperature, this ice can be converted into water and water can be converted into steam. So the animation. So what happens to the particles of this matter? What happens to the particles of this matter? Okay, let's take it. We know that. No, sir, unmute one for me before the animation. Alright. Yes.
Adul.
How does this particles arrange it in a solid solid state?
Ma'am, so particles, ma'am, they due to temperature, since there's not much temperature given to the
No,
particles.
I didn't ask that. How does this particle arrange it themselves in a solid state? Is that close together or far away from each other?
Due to the force of attraction between them.
Due to force of attraction between them, they stay closer to each other, right?
Yes, ma'am.
So in solids, the particles are closer to each other. Now what happens if we raise the temperature? Yes, the animation. Yes. Yes.
Ma'am, so if you increase the temperature, the particles gain kinetic energy and they break the bond between them.
Very good. So here we go. You have to answer that in the comment box, okay? So we know that the particles are closely arranged inside the solid. Okay, this is a solid and they are closely packed because they have a strong force of attraction between them and they vibrate in their mean position. In their fixed position, they vibrate, okay? They vibrate in its fixed position. Now what happens if we raise the temperature? You can see over here, as we raise the temperature, the particles, the particles will get more kinetic energy. So the energy gained from the heat is helping them to break the bonds between them. If they have more kinetic energy, it is easier them to move around, and if they move, they will break the bonds between themselves and they will convert into liquid state. Okay, in solid state they were close to each other and they used it to vibrate in a fixed position. Okay, they used to vibrate in a fixed position. Now what happens if we raise the temperature? As we raise the temperature, we know that temperature is directly proportional to kinetic energy. So as the temperature increases, kinetic energy of the particle increases. As the kinetic energy of the particle, they gained enough energy to break the bond between themselves and they are free to move around. Now they are free to move around. That means they just converted from solid state into liquid state, from ice to water. Now further we are going to increase the temperature. Now what will happen? They will gain more and more kinetic energy, and see it over here, they will move so fastly and again they will break the bond between themselves and they move freely and they will convert into gaseous state. So this is exactly what happens to the particles of matter when we apply temperature or when we raise the temperature. Okay, is that clear? Do you want me to repeat this animation again? Yes, sir, you can just repeat this animation again. So before, the solid was too close to each other and they used to vibrate in their position, and when we applied temperature, they broke the bond between themselves, they gained more kinetic energy, they started to move so freely, they have more energy, and here we go with a gas. So solid just converted into liquid and liquid converted into gas. Okay, solid into liquid and liquid into gas. This is exactly what happens if we raise the temperature. Okay, yes. Do we have any doubt? Any doubts? Yes, we have the hand raised there. Mohammed, right?
Yes.
Yes, Mohammed.
Yes, ma'am. I have a doubt here. So, if the kinetic energy increases, does the interparticle force of attraction decrease?
Yes, definitely. Interparticle force
Okay.
of attraction decreases and they break the bond between themselves.
Okay, fine. Okay.
Yes. Then, who else? Ishan. Yes, Ishan. Tilt your camera a bit lower. I'm not able to see your face.
Actually, this is the maximum because
Oh,
I'm on
maximum.
PC.
Alright, no
And,
issues. No issues, no issues. Yes, Ishan. What's the
Yes,
doubt?
Ma'am, so when when they build up kinetic energy and they collide onto another one, they
Yes.
actually pass on the kinetic energy, right?
Yes. If they collide with each other, they will pass the kinetic energy and they will also collapse with the walls. Yes, the energy
What
will be
happens
increased
when
in
they
that
actually
case.
collide with the wall?
Yeah, they can collide with the wall, right? If they collide with each other, they can move so fastly, right? The kinetic energy can be passed and the energy will be increased. So the speed of these particles will be increased in that case. When they collide with each other, the speed will increase, right?
Yes, ma'am.
So the speed of the particle will increase and they move freely. Yes, and fastly.
Thank you, ma'am.
Yes. And there,
Christy.
Christy, yes, Christy.
Yes, ma'am. Ma'am, my doubt is that you said right, temperature is directly proportional to
Kinetic
kinetic
energy.
energy. So could you please explain that for me?
So temperature is directly proportional to kinetic energy as he have shown over here. So as the temperature increases, kinetic energy of the particles also increases. So the temperature is directly proportional to kinetic energy. As the temperature increases, kinetic energy of the particles also increases. Okay, that is exactly temperature is directly proportional to kinetic energy. If the temperature increases, kinetic energy of the particle increases. If kinetic energy of the particle increases, the movement will be faster because they have so much energy in them, so they move so freely. You can see over here, as the temperature increases, before they were moving a little bit, and as the temperature increases, kinetic energy of the particle increases, so they move so fastly. Okay, clear? Yes, very good. Now, one more was there.
Rehan.
Rahan, yes, Rahan.
Ma'am, I wanted to ask, like, is there a limit for a particles? Like, is there a limit to how amount of kinetic energy you can gain?
No, there's no limit for them. No.
Okay.
Abid.
Abid, yes, Abid. Can you talk a bit louder? You're not audible for us.
Ma'am,
Ah. It is not clear. It's not clear. A bit louder.
Ma'am, so material seems to be broken with
Yes, it will break down. The bond between them will break.
so that means the intermolecular
Yes, the interparticle force of attraction will be breaking and the intermolecular space will be increasing. Okay. interparticle force of attraction will decrease, whereas interparticle space will increase. Okay? Yes. I hope that's it. That's it, right? And who's that, sir?
Azalifa.
Azan.
Azalifa.
Asalfa. Ma'am, if the temperature
Yes, ma'am,
changes. Wait a second, okay?
Uh,
Change the liquid. Okay, fine. Yes, Asalfa.
When the kinetic energy increases and the particles move faster, then it converts into liquids and gases, the solid.
Yes.
But when it converts into gases, does it diffuse into the air?
Definitely, it's going to diffuse. Yes, when the water is boiled, right, it will convert into gaseous state. That is water vapors, and this water vapors will mix with the other gases that is present in the air. They diffuses in the air, right? You cannot see the water vapors anymore because they diffused into the air, right? So gases have the property of diffusion. Yes. Yes. Shall we move forward then?
Neha.
Neha. Yes, Neha.
Ma'am, yesterday I asked you a doubt, right? Sorry, not yesterday, day before yesterday.
What was
About
that?
the water vapor when you just put on a lid on
Yes.
something
I
which is
remember.
boiling.
Yeah, I remember that.
So now you're telling that as the temperature increases, the kinetic energy increases, and because of the kinetic energy, the particles will lose their force
Bonds
of
between
attraction,
them.
right?
Yes.
But now again, taking my example of the lid on
The
the
top.
boiling thing.
Yeah.
So here we have water vapor,
Mm.
and now the temperature is increasing, but
Yes.
then the vapor is turning into water droplets.
Yes.
Is that supposed to be an exception?
No, that's just because we are putting a lid. That means we are applying the pressure. In high pressure, they use it to condense, right? So the gases will convert into liquid state and this process will repeat, right? We are applying the pressure on the lid. So at high pressure, it will just convert from gaseous state to liquid state. That's exactly what happens over there.
Got it.
Okay. So only doubts. The portions are not getting forwarded. Yes. Okay. Who's that? Yes, Christy. When will
Yes,
I
ma'am,
complete the
I know
portions? Yes, Christy.
What do you mean by this interparticular attraction and space?
Yes. The force of attraction between two particles is called as interparticle force of attraction. Okay. The force of attraction between the two particles is called as interparticle force of attraction. And the space between them, the space between these particles, okay, the space between these particles is called as the interparticle space or intermolecular space, okay. Intermolecular space or interparticle space. Space between the particle is called as intermolecular or interparticle space. And the force of attraction between these two particles is called as intermolecular force of attraction or interparticle force of attraction. Okay?
Yes, ma'am.
Yes. Alright, moving forward. Yes, sir. Two more. Just comment the question, okay? Okay. If there is not space, the space will be there, okay? The space will be there even in the solid. If they are closely packed, the space will be there. For example, these are the particles of solid and you can see the space over here, right? The space over here, you cannot fill that space and I can call that space as void. Voids will be there. So we cannot avoid the space. So space will be there, okay? Voids will be there. You will study that in the higher classes about the voids. I'm not going to confuse with the voids, okay? Space should be there, will be there, okay? Yes. Moving forward. Who was that, sir?
Amir.
Amir, yes, Amir. Why your camera is off? Amir?
Okay, teacher,
Wait, before that, turn on the camera.
my camera will not turn on.
Will not work? You have to fix that in the next class, okay? No exception.
Okay.
Will you do
My
that?
doubt is, my doubt is that if we put heat on ice,
Mm-hmm.
the molecules will move, right? That's
Yes.
why the ice melts.
Yes, The molecules will move, they break the bond between themselves, they gain the kinetic energy.
But when molecules are together, then the ice will form, right?
Yes, when we cool the liquid, we'll get the ice. They will come together, the force of attraction will be greater, the space will be less, so we can get the liquid, solid back from the liquid.
Okay.
Okay. Alright, so you can remove the animation for me. It's removed, right? So, in the conclusion, I can write that the solid, I can summarize that solid can be converted into liquid and can be converted into gas by applying heat. Okay, we can summarize it like this. And what happens if we cool them? Just reverse it, okay? When we cool the gas, we will get the liquid. When we cool the liquid, we will get the solid. So summarize it. We can summarize the change of state of matter into this. Okay, we can just summarize it. Okay, the change of state of matter, we can just summarize it. Okay, like 5, 6, 7, 8. Okay, fine. No worries. Yes, okay, quickly write it down. Solid, when we heat it, we can convert it to liquid. Liquid, when we heat it, we can get the gas. When we cool the gas, we'll get the liquid. And when we cool the liquid, we'll get the solid. Now unmute one for me, sir. Izan. You have to answer it quick, okay? Don't even think what the question is, but you have to answer, okay? Without thinking, you have to answer. Shall I ask the question then? Ready?
Yes, ma'am.
Yes. What is the process that we can call the conversion of state of matter from solid to liquid?
Solid to liquid, boiling.
Solid to liquid is boiling.
Not boiling, ma'am. The other thing, it's
Ice into water.
the melting.
Melting. Okay. Next one, sir. Chandru. Yes, Chandru.
Yes, ma'am.
What is the process where the liquid converts into gas?
Boiling.
Very good. Now the next one, sir. Tirtha. Wait a second. Melting. Okay, Tirtha.
Yes, ma'am.
What is the process where the gas converts into liquid? Don't think, just answer. Gas into liquid. In the glasses, have to remember the glass. In the windows,
Condensation.
condensation. Very good. Don't forget these terms. Now the next one, sir.
Rishan.
Rishan. Rishan was so surprised. Did you call me, ma'am? Rishan. So what is it called? Liquid into solid. What is that process called as? Liquid into solid. You're not audible. Just can you repeat that again? I can read from your lips. Come on. Just tell that. I can read from your lips. Come on. What is the process from the liquid to solid called as? He's thinking so hard. Come on. Starts with the F. Fridge. Come on. Liquid to solid. Freezing. Very good. So all you have to remember the example of ice, water and steam. Okay. Water and steam. You have to remember this. Ice into water and water into steam. All you have to remember is this, and also you can remember all these terms. Okay. So ice into water, we know that it is called as melting, and water into steam, it is boiling, and steam into water, it is condensation, and water into ice, it is freezing. We all know these terms, but still confused with all those things. So I'm moving forward again. Moving forward with the next one, we have some scales to measure the temperature, which is an important topic from the chapter. Okay, you have to learn it. Okay, you have to learn it. There is no exceptional case in reading this. Okay, scales of measuring the temperature. Scales of measuring the temperature. So can anyone tell me which is the SI unit for the temperature? Which is the SI unit of temperature? Just comment it, okay? Just comment it. Which is the SI unit? SI unit. SI unit. SI unit of temperature.
Yes, we have.
Is it Celsius?
Kelvin, Celsius, and joules.
Degree Celsius.
Fahrenheit. Yes, we have.
We have everything,
yes.
but the actual SI unit of the temperature is nothing but Kelvin. Okay, so applause for the Kelvin students. Okay, it's not Kevin, it is Kelvin. Okay, Kelvin. Okay, is there anyone with the name Kevin over here? We have a student Kevin in 8th standard, not in 9th, I guess. Okay, it's not Kevin, it is Kelvin. Okay, Kelvin is the SI unit of temperature. Don't ever forget this. Okay, it is Kelvin. Okay, it is Kelvin. Kelvin is the SI unit of temperature. Just repeat after me. Repeat after me. Say it loud. Kelvin is the SI unit of temperature. Okay, say it loud. I can see your lip syncs. Very good. Kelvin is the SI unit of temperature. Now we have to learn. So many have given me the answer Celsius. Okay, Celsius is not the SI unit of temperature. That is the scale of temperature. Kelvin is also a scale of temperature. Okay, we have three scales: Celsius, Fahrenheit, and Kelvin. We are not going to talk about the Fahrenheit right now. All the thing that we are going to learn is Kelvin and the Celsius scale. Okay, we have to learn two scales now: Celsius scale and the Kelvin scale. So they will give the points whether in Celsius scale or Kelvin scale. You just have to convert the scale. That's all you have to do. It's very, very simple. Now the question is how? How? Okay. Yes. Here we go. If, okay, just imagine. If they have given the temperature in Kelvin scale. Okay. If they have given the temperature in Kelvin scale and ask you to convert, I'm sorry. If they have given the temperature in Celsius scale and if they ask to convert the Celsius scale into Kelvin scale, okay, so degree Celsius into Kelvin, okay, degree Celsius into Kelvin, you just have to convert the temperature from Celsius scale to the Kelvin scale. All you have to do is just add 273.16 to the Celsius scale. Okay, they have given the Celsius scale. All you have to do is what? Just add 273.16 over there. Okay, let me repeat that again. In the question paper, or if someone asks you to convert the temperature from Celsius scale to the Kelvin scale, Celsius to the Kelvin, okay, Celsius, this is not round, okay, that was my design of border, okay, I'll rub it, no confusions, okay, yeah, Celsius, just the box is enough. So Celsius to Kelvin, degree Celsius to Kelvin, all you have to do is just add 273.16 to the Celsius scale, that is Kelvin scale is equal to degree Celsius plus 273.16. If this 16 is so hard for you, for the convenience, just add 273. But don't ever forget the 273, okay? So Kelvin is equal to degree Celsius plus 273.16. So if you can't remember the 16 over there, it's just fine. For your convenience, you can just write degree Celsius plus 273. That is more than enough, okay? This is more than enough. Okay? Kelvin will be equal to degree Celsius plus 273. Very nice. Okay, you all are math experts. I know that. So it will be easier for you, right? Just add 273. What is that in it? Okay, now I have a question. 0 degrees Celsius, which is nothing but the melting point of ice. Melting point of ice. 0 degrees Celsius is the melting point of ice, right? Ma'am, it's Kelvin. Yes. Ma'am, if we write like that, we will get the right answer. Definitely you are going to. Definitely. So melting point of ice is 0 degrees Celsius, and they have asked the 0 degrees Celsius will be equal to what? So you have to just convert the degree Celsius into the Kelvin scale. Okay. Yes. So just convert it. How will you convert? Just give me the answers in the comment box. Give me the answers in the comment box.
Yes.
We have the answers. So you understood this, right? Did you understood the concept? Don't by heart it. Don't ever by heart it. You will forget it. So understand the concept. Okay, understand the concept. Just add 273 when the scale is in degrees Celsius. Okay, add 273. It is addition. It is addition. Ma'am, I want that person who gave 263 all day.
Okay.
Yes, did everyone answer? I want the answer from everyone. As I said, you have to answer. There is no exceptional case over here. Even though we are studying the chemistry with so many exceptional cases, there is no exception in answering this. Okay, ma'am, I didn't understand this. I will explain it. Unmute herself.
Okay.
Is that?
Yes, Sri Lakshmi.
Sri Lakshmi.
Sri Lakshmi, Sri.
Yes, what is the answer that you got?
273.
Is it 273?
No, you commented 263.
You gave me 263. Okay, it is nothing but 273.16 or just 273 is more than enough. But the one thing that you forget to add is nothing but the unit Kelvin. Without writing the unit, you are not going to get even 0.5 marks for this. Okay, so without the unit, no one is going to give the marks. So don't ever forget to add the unit. Okay, Kelvin, K. Kelvin is K, right? Yes. Now, Christo, I want Christo. Yes.
Okay.
Yes, Christo. Christo?
Oh, wait.
Christo is not here yet. Christo, can you raise your hand? Just raise your hand, Christo. Yes, there we go.
Yes, here I am.
Christo, what is your doubt?
Ma'am, I don't have doubt.
Have you understood this?
Yes, ma'am.
Yes, I saw your comment over there. That's why I called you. Now, who else have doubt on this? We got this answer just because the given thing was in degrees Celsius scale. So it was in degrees Celsius scale. So all we had to do was just add 273. In order to get Kelvin, we want to get the Kelvin, right? So just add 0 plus 273 or 273.16. You will get 273.16. That's it. And don't forget the unit K. Okay. Still any doubts? Any doubts? Yes, Rishikesh. Rishikesh.
learned grade 7.
Huh?
We learned grade 7 for Kelvin.
Yeah, it is Kelvin. We are converting from Celsius scale to Celsius to Kelvin. What?
We learned in grade 7.
You already learned in grade 7. Alright. So you don't want me to repeat this again? Alright, Rishikesh. Very good. So, is there anyone with the doubts? Is any doubts? Anyone? No, right? So I have a question for you. Is everything clear for you? I'm asking again. Yes, ma'am. Mehrab. Yes, Mehrab.
Mom,
Ah.
what are they doing with the Celsius scale? What they doing?
I didn't get it.
Mom, if they're doing with the Celsius scale,
So they will give the Kelvin scale. So you just have to convert to Celsius scale. I will teach that, okay? No worries.
like if they give like convert Kelvin scale to Celsius, so we have to minus.
You know the answer, right? We'll study that, okay? We'll study that. We'll study that. Unmute him, man.
Ruben. Yes, Ruben.
Yes, Meher, we'll learn it, okay? Yes, who's there, man?
Ruben.
Ruben. Ruben.
Hi, ma'am.
Hello, what's the doubt?
How are you?
I'm doing great, Ruben. Thank you for
Ma'am,
asking
I have
me.
a doubt in the
Yeah.
multiple scales of movement. How do you get this, ma'am? I didn't understand the calculation.
Alright, so they have given a value with a degree Celsius, okay? Okay. They have given a value of the scale with a degree Celsius and they will ask them to convert the degree Celsius into Kelvin. Okay, here, degree Celsius into Kelvin. That's all we have to do. Okay, so what we will do, in order to get the Kelvin scale, we have already have the value of degree Celsius, right? You already have the value of degree Celsius. Now all you have to do is just add 273.16, okay? Just add 273.16, you can just convert the value from degree Celsius to Kelvin. Okay. Now for example 0 degrees Celsius. It is already given over there. So all you have to do is what? Now answer me. What do you have to do? We have given the value 0 degrees Celsius. So in order to convert 0 degrees Celsius into Kelvin scale, what do you have to do?
We have to addition.
Add 273.16. What will be the answer then?
273.16.
Yes, that's it. And what about the unit?
Kelvin.
Kelvin, K. Don't ever, I'm repeatedly telling this, don't ever forget to write the unit, okay? Don't ever forget that. Is this one clear for you?
Yes, ma'am.
We have
Yes.
one. No.
Alright, now here we go with the question time, okay? Convert the temperature. This is how they are going to ask the questions, okay? This is the model question for you and you are going to answer. Convert the temperature of 200 degrees Celsius to the Kelvin scale. And if you got the answer, just raise your hand as the cat do. Okay, raise your hand to answer this.
Yes,
And also give me the answer in the comment box too.
We have a lot of hand raises.
Lot of hand raises. It's difficult to pick one from you students.
Okay.
Yes.
Is that
Yes. Unmute someone from not the hand raisers, ma'am. Okay. I don't want the hand raised students. They know the answer. There will be someone like will not raise their hand forever. So I want that student who's not raising the hand.
Yes, Nevin. Oh, Nevin. Yes, Nevin.
Nevin.
Nevin Joseph.
Nevin. You didn't get the answer?
Nevin.
Nevin?
Will you
Thomas.
unmute? Nevin.
Nevin, please unmute.
Nevin Joseph.
Yes, ma'am.
Yes. Did you got the answer?
I'm thinking of convert to the questions.
Now you are reading the question. Just tell me how will we convert degree Celsius into Kelvin? What's the equation for that? What is the equation for that? Kelvin scale is equal to? Thinking so hard, you guys told me you understood everything, right? Have you written down everything?
No, ma'am.
No. Why?
I joined little late, ma'am. Before, I joined 7:15 or something like that.
I have just explained this a few minutes ago. Right?
15.
Why are you late? Why were you late?
Ma'am, I just reached from school, ma'am. I reached home.
Will you repeat this
I will
again in the
check,
next
like,
class?
it's 45, 650 something.
Will you repeat this again in the next class?
No, ma'am.
Never. Right?
Yes, ma'am.
Alright.
Let's ask
We'll
Jivan.
go for the next one. Yes.
Jivan.
Did he raise the hand?
No.
No. Why, Jeevan?
Ma'am, I raised my hand.
Raise your hand. Okay, unmute him, ma'am.
Okay.
I don't want the hand raised students. From the back, ma'am.
Okay. Jivan, I think. Okay, let's unmute.
Hmm.
Tom.
Tom,
Yes, ma'am.
did you answer this question?
Is it 473.16 Kelvin?
Then why did you raise your hand?
I should have raised my hand.
I have told you, if you have got the answer, just raise your hand, right? Yes, Tom, how did you get the answer? Lead me to the answer now.
200 degrees Celsius plus 273.16.
Plus 273.16, and what is the answer?
473.16 Kelvin.
16 Kelvin. Very good. Very good. Is everyone got this answer? Did everyone got this answer? Just give me a thumbs up or a heart shake if you got the answer.
But somebody got 200K.
200K? Who's that?
Tirtha.
Tirtha, how did you end up with the 200? That was degree Celsius scale, right? How did you end up with the 200 then? Alright. Ma'am, I have a doubt. Who is that?
Okay. Samuel.
Samuel, yes, Samuel. What's your doubt? Yes, Samuel.
Now my teacher taught us that we have for converting we have to add 273.3.
273 point?
16.
15. 15 and 16 is almost same, right? No worries. But the actual one is 16, okay? 273.16. 15 is also almost nearly to that, right? No worries. Alright. It is 16. It is 273.16. The answer, it was very easy. Very good. Good to hear that. Yeah, it was very easy, right? Now we have learned how to convert degree Celsius into Kelvin. Now the thing is, what happens if they give the value in Kelvin scale and they ask it to convert into Celsius scale? Okay, they have given the value in Kelvin scale. Now we have to convert into Celsius scale. Okay, what will we do? Say with me, it was easy. Okay, we have added 273.16 to make it into Kelvin. Now, to make back into Celsius scale, exactly, we are going to subtract it. Very good. We are going to subtract it. So, temperature on Celsius scale will be equal to temperature on Kelvin scale minus 273.16. Very good. So, degree Celsius will be given and we have to convert it to Kelvin. Okay, I'm sorry. Kelvin is already given, we have to convert it to Celsius. So, Kelvin plus, minus. What's wrong with me? Yeah, it is minus 273.16. Okay, this is the equation. We have the scale in Kelvin scale and we have to convert into Celsius. We have to convert into Celsius. Here we go. Degree Celsius. Okay, Kelvin into degree Celsius. All we have to do is just subtract the same number, 273.16. We'll get the answer. Okay, just subtract it, just opposite to that. Teacher, I want to answer the next question. Okay, Daniel. Okay, Daniel. I will call you. Okay. Ma'am, is it fine if we do 273 instead of? Yes. If you are so concerned with the 273.16, just 273 is enough. Okay, just 273 is enough. No worries. It will be better with the 16. Okay, it will be better with the 16. I will not tell you to avoid that. But if you are so much struggle to remember the 16, 273 is just fine. Okay, since you have all understood this, We'll go for the question. So degrees Celsius is equal to Kelvin minus 273.16. To convert Kelvin into degree Celsius. Now the question is, convert the temperature of 400 Kelvin to Celsius scale. 400 Kelvin. So Kelvin scale is over here. You have to just convert into Celsius scale. What will you do? So in the subtraction, this 1/6 will be a little more difficult. So you can just remove that 1/6, okay? If you are struggling to calculate this, you can just remove the 1/6 and subtract it. No worries, okay? Now, how many of you have got the answer? Raise your hand. Raise your hand if you got the answer. Raise your hand if you got the answer. Everyone, okay? If you got the answer, raise the hand. We'll pick someone from not raising hands. Did everyone raise their hand?
No.
No, a lot of them are not raising the hand yet.
Yes.
Yes, ma'am.
Sahajalin.
Sahajalin.
Sahajalin called.
Sahajalin. Sahajalin? Are there?
You are getting a notification, right?
Just unmute, okay? Unmute. Are you able to unmute?
Are you listening? You just asked.
Hello? Am I audible for you? Yes.
Oh, so
Just not able to do that.
Okay.
Okay, fine. No worries. Okay, no worries. Okay. We'll go for the next one.
Next one. Azalfa.
Azalfa. Very good. You have to send the answer. Yes, Azalfa.
216.85.
To 100 and?
No, 0.85.
To 6.84? 85.
Yes.
Is this the answer that you got?
Yes.
You got the answer. You got the answer and still not raising the hand. Why? I've told you, if you got the answer, just raise the hand. What is there to raise the hand? I'm not telling to raise your hand. It is just a sticker, right? You can just press that. It's so simple, right? Why are you so struggling to raise your hand?
Yes.
Alright, and
I didn't know it was the right answer or not.
I have told you many times, I don't care whether it's a wrong or right answer. You just have to interact with me. Okay, I don't care. Really, I don't care whether it's a wrong or right answer. Even I will tell the right answer, right? You can just correct it by that. So no worries. Okay. Yes, I'm with someone else, ma'am. Thank you so much for the answer.
Okay. Yes. Unmute.
Where's Daniel? Daniel told me to
Okay,
unmute him, right? Yes, Daniel. Daniel.
Wait. Daniel.
Where's Daniel? Daniel was waiting for us.
A lot of hand raises, that's why. Yes.
Daniel is here. Daniel, is this right answer?
Teacher, I got 127 Celsius.
127 Celsius?
Yes, teacher.
So how did you got that answer?
So I minus 400 minus 273.
400 minus 273, right?
Yes, teacher.
Yes, that's correct. 127. So, if you just put 1/6 over there, you will end up with this answer, okay? 400 minus 273.16, it is 126.84. Okay? Yes. Did everyone got how does we end up with this answer? Is everything clear for you? Is everything clear for you? Ma'am, lower everyone's hand. Or you can just lower your hand by yourself, okay? Lower your hands.
Yes.
Now raise your hand if you have any doubt. or just lower your hand if it doesn't have any doubt. We'll move forward with the next one. That's an important topic coming by, and we have 2 more questions to attend.
Yes, we have hand raises.
We have hand raises. Can you just comment the questions? Will you do that? Can you comment the questions? Niranjan, then who's that?
Okay. Oh.
Rishikesh,
Shayan is there.
Shayan,
Abhirami,
Aiza, please
Niranjan,
comment the questions,
Ram,
okay? Comment the questions. Comment the questions, okay? Here we go, the next question. Here we go, the question. This will be your homework, okay? Homework. Quickly take a screenshot. Don't write it, take a screenshot, okay? Take a screenshot and write it later. Take a screenshot. It is in Kelvin scale. Okay? It is in Kelvin scale. You have to convert into Celsius scale. So 100 Kelvin will be equal to what degree Celsius? You know the equation? Just do it, okay? It will be your homework. Did you took the screenshot of it? Did you do that? Very good. Ma'am, you can either get 273 or 273.16, right? Both of them are correct, okay? Both of them are correct. If you are struggling with the 16, subtraction of 16 will be a little difficult. If it is not difficult for you, it will be better, okay? So if the subtraction and addition is difficult for you, you just go for 273. Did you took the screenshot of it? Niranjan, come in the question. I'll read it, okay? I think nothing is correct from this answer. We'll check it in the next session, okay? Just answer this, okay? Try to answer this. Alright. The next question. This is also a homework. Take a screenshot. Quickly take a screenshot. Boiling point of water. You know what is the boiling point of water, right? In Celsius scale, we have taught that. What is the degree Celsius of boiling? We know that, and we have to convert them into Kelvin, and which of them will be the right answer. Again, we have 2 homework questions, and quickly take a screenshot of it. Ma'am, if we forget the 16,
it will be
alright.
It's
Hope everything is clear for you. Did you do that? Let's go for the next topic. It's even more important than this. Okay. Yes, Sharmi, give me thumbs up. Give me thumbs up if you are ready for the next topic. Not a thumbs up. What happened, Daniel? Daniel is like, no, ma'am, I'm not ready at all. Why, Daniel?
Teacher, our previous answer was 120. Previous answer? No.
For this question?
No.
For this question?
Yeah.
Here's the answer.
126.84. Okay.
If you got 127, it's fine. If you got 126.84, it's very much correct. Both of them are correct, okay? Yes, it was easy. Alright, I know those things are very easy. Daniel, what was your concern? Why did you give me like this? Thumbs down. What was the reason for thumbs down?
I think they have some confusions in
Confusion
minusing decimal points.
Okay,
That is
decimal
the
points.
problem.
So if you are difficult with the decimal points, just don't go for that, okay? Just remove that 16. Go for 273. It's fine, okay? 273 is fine, okay? Don't go for the decimals. Don't go for the
They are
decimals.
thinking like if we subtract from the old number, then we can add just 0.16 after that. It's not correct, right?
No, it's not that. No, it's not correct.
Okay.
You all are math expert, right? I'll tell this to Anila ma'am. You're struggling to subtract 16. When I see her, I will definitely going to tell that. You're struggling with the 16. Alright. Shall we move then? Very good. Repeatedly I am telling this. Don't get the wrong answer by using the decimals. So just avoid, okay? If you are 100% sure with the decimals, just write that answer. Or else just subtract 273, it's fine. Okay. These are all 273 by using 273s. Okay. Okay. The answer will be using 273s. So not use the 16. It's my opinion. Don't go for 16. So the animation for us. Yes. We have a animation over here, don't play it, sir. So you are going to watch it carefully and I'm going to ask questions, okay? And I'm definitely going to ask the questions. So everyone listen to me and watch the animation carefully. I will not going to repeat this animation again, so just watch it carefully. I will ask the questions. If you don't answer the question that I'm asking, impositions are waiting. Play the animation for us, sir. Okay, I'm not going to talk anything, just watch the animation. Did you saw that? I'll just repeat it again. Yes, sir, you can play it again. Watch it so carefully, the scale. Watch it so carefully. Yes, that's it. So, unmute someone for me, ma'am.
Okay. Yes, Abid.
Abid.
Oh no, ma'am. Oh, okay, it's okay.
Why, ma'am?
No.
So, Abid, what is the melting point of ice?
0.
So, shall I write over here, sir? It's not there. Okay, I cannot. Okay, fine. No worries. Okay, so what is the melting point of ice? It was 0 degrees Celsius, right? Yes. What was the boiling point of water?
100.
100 degrees Celsius, the boiling point of water. Very good. Now the next one, ma'am.
Okay, R is more.
I have a doubt.
You have a doubt. Yes.
In the last question, I got the answer 127.
But the homework question? Was that a homework question?
No, the question which you discussed.
27. Did you got 127?
Yeah, 127.
Yeah, that's perfectly fine. You haven't added 16, right? Yeah, that's totally fine. If you're struggling with the 16, don't do that, okay? Don't go for 16. It's perfectly fine. Okay?
Ma'am, will you get marks?
No, they will not going to reduce the marks. No worries.
There are actually confusion. They all have that confusion.
All have that confusion.
Yeah.
So 273 is just enough and fine, okay?
Okay.
It's fine. So melting point of ice was 0 degrees Celsius and boiling point of water was 100 degrees Celsius. I hope you watched the animation so carefully. Now unmute one more for me, ma'am.
Yes, Muhammad Aris.
Aris,
You are not audible.
Aris, you're not audible for us.
Okay, let's unmute Zuhair.
Zuhaira.
Zuhair was like, am I invisible here? My hands hurts by raising hands.
So
Yes,
we
yes.
have so many hand raises
Yes,
over
yes,
there and we missed it, okay? No worries, Zuhair. Here we are.
Everyone is commenting like, teacher, I want to answer.
Everyone wants to answer.
Thank
Thank you. I can see
Okay.
your comments, okay? No worries.
Okay,
Yes,
Zuhair.
Zuhair. Unmute now, Zuhair. Did you watch the animation so carefully?
Yes.
What
Hello?
happened? Now let me ask the question.
Can you hear me now?
Yes, I can.
What was the question?
What happens when the temperature reaches to 0 degrees Celsius?
Ma'am, I'm answering.
Both of them
The
are
answers,
answering
both
actually.
answers.
Both of them are answering. Who's that both of them?
Actually,
Do we have
Aris-
two, Suhair?
No,
So
actually,
my
Aris
question
and also Zuhair, both of them are answering.
Oh, Aris, wait for a second, okay?
Okay, ma'am.
Okay.
Okay.
Fine. Zuhair,
Okay.
did you see what happened when the temperature reached 0?
The ice melted.
Ice
So
melted.
it means that the melting point is 0 degrees Celsius. Then after that, the water was boiling at 100 degrees Celsius, so which means boiling point is 100 degrees Celsius.
Alright. Now thing is, did you really watch at 0 degrees Celsius? For a long time, the temperature was constant. Am I right?
Yes.
Did you really observe that?
Yes, before it was like
see here?
less. Yes.
The temperature at 0 degrees Celsius just stopped. And after melting, after the complete melting, the scale was increasing then. Am I right? And at 100 degrees Celsius, again the temperature just became constant again until they boil. Am I right?
Yes.
Did everyone observe that? Now, unmute him, ma'am.
Okay, Aris.
No, Aris.
Yes, Aris.
Aris.
Hello, Isma.
What happens if we raise the heat?
Ma'am, so first when we raise the heat, it was ice before and it melts and turns into water, and when we raise the temperature to 100 degrees Celsius and it evaporates.
So when it is definitely clear that when we heat it, the temperature will increase. Am I right?
Yeah.
Yes. As we give heat, as we provide the heat, the temperature is definitely going to raise from the thermometer.
Yeah.
Now we are constantly providing the heat energy, and again the temperature stopped at the certain point of 0 degrees Celsius. So I am continuously providing the heat energy. Where does this heat energy gone? Without raising the temperature, where does this energy gone? Do you have any guess? Why the temperature has stopped at 0 degrees Celsius after before melting everything? Before the ice was completely melting, the 0 degrees Celsius was not at all moving. Right? Why? Where does this energy goes? The temperature was clearly not raising. We know that as the heat energy provides, the temperature should raise. But this temperature was constant at this level. Right? So, can you play that again? Yes. Temperature was raising when we provide the heat, but at 0 degrees Celsius, they just pause this. There. And you have to pause over here. So, after melting, after the complete melting, then only it started to move. Before that, it was constant over there. Is there any answer over here? We have the hand rises. Very good.
Yes, we have a lot of hand raises.
Yes, ma'am. Unmute one for me.
Okay, yes, let's unmute. Srita.
Srita, why did this temperature just became constant over here? At 0 degrees Celsius, what happened?
As it reaches 0 degree Celsius, which is the melting point of ice, the heat supplied will be absorbed by the contents of the beaker, which is ice and water, and hence it will all be utilized by the particles of water, and it breaks down all the forces of attraction.
Oh, very good. That's it. That's it. Good job. So now listen to me carefully. Listen to me carefully, okay? So we use this heat energy to convert the change of state of matter. We have to change the state of matter, okay? From solid to liquid and liquid into gas. That is why we are providing the heat energy. So that is why we are increasing the temperature. But we know that melting point of ice is just 0 degrees Celsius. So after reaching 0 degrees Celsius, we know that ice will melt. It is a melting point. Temperature at which and solid melts into liquid. At that temperature is called as melting point of ice. So melting point of ice is nothing but 0 degrees Celsius. So the 0 degrees Celsius is reached, and The ice is just converted into liquid, right? Yes, by during that process, they absorb those heat energy. So until it reaches 0 degrees Celsius, the temperature will be increasing by using that heat. The temperature will be increasing, but at the certain point of 0 degrees Celsius, all the particles of ice is just going to utilize the rest of the heat energy. So they are utilizing the rest of the heat energy. That is exactly why the temperature became constant, not increasing anymore. Just because all the heat energy providing just after the 0 degrees Celsius will be utilized to convert the state of matter from ice to water. They use all the heat energy. Okay, they use all those heat energy. That is exactly why the temperature is not raising. And the heat energy that we are providing right after the 0 degrees Celsius is called as the latent heat. The latent heat. Okay, without listening carefully, you will not get this concept. Okay, just listen to carefully. So I will explain this again. Okay, so we saw that. Replay this. So we saw that when the heat energy is provided, temperature is going to rise until 0 degrees Celsius, and after melting, yes, suppose it. And after 0 degrees Celsius, the temperature became constant, and rest of the heat energy right after the 0 degrees Celsius is utilized by the particles of ice to convert into the liquid state. They use those energy to break the bonds between themselves, and they got more kinetic energy. They absorb those kinetic energy. That's exactly why the temperature was not increasing. And the heat energy that is absorbed right after 0 degrees Celsius is called as the latent heat. Okay, latent means hidden. Okay, we cannot see where that heat gone. The temperature is not heating, and where does this heat gone? It's hidden. That is the meaning of latent, hidden. Hidden is the meaning of latent. Okay, it's a hidden heat. It is used by the particles. It is trapped by the particles. Okay, that is latent heat. Now, shall we go for the definition for that? Shall we go for the definition? Ma'am, can you once more say the latent heat? Definitely. Here we go. Yes, sir, you can remove it. Here we go. This was my question. When the solid melts, its temperature remains the same. So where does this heat energy go? This was my exact question and I already answered it, right? And what was the answer? What was the answer? It is all due to the latent heat. It is all due to the latent heat. And what is latent heat now? It is the heat energy which has to be supplied to change the state of substance is called as the latent heat. Okay. It is the heat energy used to change the state of matter is called as latent heat. So the heat energy provided after 0 degrees Celsius will be the latent heat. In the previous session, someone asked me, literally everyone asked me, which state does water will be in 0 degrees Celsius. I have told you, when we raise the temperature, or when we provide the heat energy, it will convert into liquid, or when we decrease the temperature, it will just convert into ice. That is all because of the latent heat. I was almost waiting for this question to cover up to explain those things. Okay, so this is the exact reason for that. Latent heat. 0 degrees Celsius will remain there. Okay, if we provide more heat energy, temperature will not be increased. All those energy will be used up to change the state of matter from ice to water. Ice to water or water to water vapor. Okay, we are not going to talk about the water to water vapor now. You will get it. We will be getting confused with that. We will study later. Okay. Okay. Was that clear? Was that clear? So many hand raisers now. That means they have a lot of doubts. Unmute one, ma'am.
Oh, yes, Christy.
Christy.
Christy, should we
Yes,
go?
ma'am. Ma'am, so my doubt is, So, ma'am, you said when ice is converted to water, the heat which is supplied is latent heat. So
Is supplied as latent heat.
so as soon as the ice is completely water, the energy which is supplied is not at all latent heat, right?
It is not latent heat then. It is already converted, okay? The state is already converted, so it's not no more latent heat. It's already converted.
Okay.
Now the temperature will increase right after melting. After the complete melting, the temperature is going to increase.
Yes, ma'am.
Latent heat is nothing but the heat energy just used to convert the ice into water. It's latent heat, or water into water vapor. It's latent heat. Okay, just the energy. A small amount of energy that is absorbed by the particle is called as a latent heat. Yes.
So if you convert water into ice, won't it be constant at zero? So what will you call that heat?
It is also a latent heat, okay? They are all latent heats. To change the state of matter, whether it is in solid to liquid or liquid to solid, it's all latent heat. Okay, it's all latent heat, but we have certain points like latent heat of fusion, latent heat of freezing, latent heat of vaporization. They are all coming, okay?
Okay,
so they are all commonly called as latent heat. No matter whether it is solid to liquid or liquid to solid or liquid to vapor or gas to liquid, no matter what, it is just the latent heat. Yes, Rishikesh. You have learned this in 9th grade, right? Or 8th grade. Rishikesh?
Yeah, ma'am, latent heat is supplied to change the state of substance. Is called latent heat.
Yes.
Ma'am, in melting point of ice is
0 degrees Celsius.
When
Yes.
What will be the boiling point of ice?
Boiling point of ice. Will the ice boil? Have you ever seen ice boiling?
No, then there's no boiling of ice.
There's no boiling of ice, so there is no boiling point for ice. There's boiling point for water. It is 100 degrees Celsius.
Yeah.
Yes, the next one, ma'am.
Mass.
Mass. Mass?
Yes.
Yes.
Ma'am, like when the solid melts, I think I should be wrong, but then, like will the energy like this?
Energy?
Not energy, I mean like it's like tea or something. It's like like.
What?
Was that a question?
No, it is an answer.
It's an answer. Alright. Alright, Mass. Next one, ma'am.
Rahan.
Rahan.
No, Rahan don't have the...
Lower the hand. Okay, fine. So no doubt. Mehrab. Yes, Mehrab.
Yes, ma'am.
Ma'am, you said latent heat it's used to preserve. It's used to preserve.
It's not using to preserve. It is using to change the state. We are not preserving anything over here. We are just going to convert.
Ma'am, the same concept is used in gaseous state, right?
Definitely, it's the same concept in the gaseous state too.
Ma'am, but I'm confused. Like, in 0 degrees Celsius, if it melts, then how can it freeze?
We provided the heat energy now. Now, in order to just convert liquid into solid, we call them the freezing, right? So what all we have to do? We have to cool it, right? We have to lower the temperature. So, the temperature will be lowering at 0 degrees Celsius. So, the cooling energy, it's also an energy, right? The cooling energy provided will be utilized. Until then, until it gets freezes, it will remain in the 0 degrees Celsius. Okay? After freezing the water, it's just going to decrease.
Oh, yeah. So
Okay.
it will stop at 0 degrees Celsius.
It will stop at 0 degrees Celsius, and the rest of the energy used to convert the state of matter from here to here is called as the latent heat.
Okay, ma'am. Thank you.
Alright.
Okay, then. No.
It is the same with everything. Okay? Whether it is a liquid to solid or solid to gas, it's one and the same.
Yes, Abhinit.
Abhinit.
Mom, it's like in this it says latent heat is the amount of heat energy supplied to an object to change its state of matter.
Yes.
So what about if we reverse this one? Like
That's exactly what I have told you, right? So the reverse is nothing but cooling or freezing is just reversing of melting, right? So we have to convert water into ice. For that we have to cool it, right? That means temperature should be decreasing. Am I right? The temperature should decrease. And when we decrease the temperature, they will reach the 0 degrees Celsius, right?
Yes.
That is exactly the freezing point of water. Freezing point of water. Freezing point of water is 0 degrees Celsius too. So at 0 degrees Celsius, water is started to freeze because we are lowering the temperature here. We are not providing the heat energy, we are lowering the temperature. That means at 0 degrees Celsius, it will become constant until the water freezes completely. After it freezes completely, the temperature is going to lower. And the heat energy used over here to convert the water into ice is called as a latent heat.
Okay.
Okay? Yes. Alright.
Yes, Abid.
Abid. Yes, Abid.
But we're patiently waiting.
Ma'am, at 0 degrees Celsius, first at 0 degrees Celsius, the heat will stop for some time. So when it reaches 100 degrees Celsius, after it will stop.
Definitely. So we have to convert now water into vapor. Sorry. We are going to convert the water into vapor. It's V, okay? VA. We are going to convert the water into vapor. That is liquid into gas. That means the boiling point of water is nothing but 100 degrees Celsius is the boiling point of water. So, in order to convert, we have to raise the temperature. Right? We have to raise the temperature. When they reach 100 degrees Celsius, the water starts to boil, and after the completion of the vaporization, they will keep this constant. The 100 degrees Celsius will not change. The 100 degrees Celsius will not change over there, but after the water vapor, there is nothing left, right? There is no raising the temperature now. The water became vapors, right? Yeah, now we don't have to calculate the temperature now, all the water became the steam. So 100 degrees Celsius will not change over there. And the 0 degrees Celsius will not change until they change the state of matter. They becomes constant. And rest of the heat energy or the energy that we are externally providing will be utilized for the change of state of matter, which is exactly the latent heat. Okay? Alright. Now I have a question for you. Is a cold ice or ice, this is the ice, okay? Ice at 0 degrees Celsius, and we have water at 0 degrees Celsius, okay? I have ice at 0 degrees Celsius and water at 0 degrees Celsius, okay? Imagine I have both of them. And which will be cooler? Which will be more cooler? Okay, both of them are in 0 degrees Celsius, and we have talked about latent heat. Now just imagine what will be colder. Is there ice or water at 0 degrees Celsius? Which one will be cooler? If you just hold ice at 0 degrees Celsius or water at 0 degrees Celsius in both of your hands, which one feel cooler? Which one will feel cooler? Unmute one for me, ma'am.
Yes, Rima.
Rima.
Ice.
Who is that behind you?
My sister Reem.
You are learning
We're
together?
twins. Yeah, we're twins.
You are twins. Very good. So both of you are understanding everything, right?
Yeah.
Yes, very good.
No.
Now which one will be more cooler?
Ice.
Ice is more cooler than the water. That is the right answer. Ice is more cooler. Now I want the reason.
Huh?
I want the reason.
Oh, because ma'am, because solid in the solid state it's cooler in the liquid state.
No, it's not like that. No. Both of them are at 0 degrees Celsius. Then how the ice became cooler?
Because we're putting water in a container, matter is closely packed. Oh, I'm not sure. I want the answer.
Both of them?
I'll just assume.
Unsure. Very good. No worries. No worries. We'll go for the next one.
Yes. Shaheen.
John. Shaheen. John, wait for it. Okay? Wait for a second. Yes, Shaheen.
Even I think ice because it's solid, and since the particles are more, the pressure is more, and I'm not sure actually, not sure. I just support ice because.
Alright, no worries. He supported ice too.
Also, one more thing I have just add out. Ma'am, in the latent heat, you said that when it's freezing, the heat energy.
In freezing?
Hello?
Complete the question.
What
was your doubt on freezing?
Yeah. When it is freezing, it uses heat energy.
Yes, it releases the heat energy. Yes, definitely.
Oh, releases, okay.
They releases the heat energy. They have to get a freeze, right? So they releases the heat energy to the surroundings.
Okay.
Yes.
Yes, John.
John.
I think both are the same.
Both of them are the same.
Yeah, the reason is because both are at 0 Celsius and water turns into ice at 0 Celsius. So it's still the same.
Still the same. So my answer is ice. Ice will be more cooler than the water at 0 degrees Celsius. Okay, ice will be more cooler than the water. Now, the exact question is how? Both of them are 0 degrees Celsius, ma'am. Then how can the ice be more cooler than that? The answer is, that's why we have learned the latent heat at 0 degrees Celsius in order to change from ice to water. The water, the molecules was absorbing the heat energy, right? The water, in order to convert, they use it to convert. In order to convert, they used all the heat energy. So water will be more hotter than the ice because they have all the hotness, right? Because they absorbed all the heat energy. Where does this heat energy gone? It is there in the water. So water will be more hotter than the ice, right? You can just guess that, right? The ice, in order to convert, the water is absorbing more heat energy. So all the heat energy will be there. It is not going anywhere. So heat energy will be there. So water will be more hotter than the ice at 0 degrees Celsius. Even though they have both of them will be having the same temperature. But the hotness is not same for both of them. Ice will be more hotter than the water will be more hotter than the ice. So ice in my hand will be cooler. Ice will be cooler than the water. Okay, was that clear? And again, when we get a burn from the hot water at 100 degrees Celsius, we have a hot water, okay? We have hot water at 100 degrees Celsius and steam. Steam at 100 degrees Celsius, okay? Steam and hot water at 100 degrees Celsius, okay? Here. Steam at 100 degrees Celsius and hot water at 100 degrees Celsius. Which one will be more hotter? When we get burned, is it time already? Yes. Yeah. When we get burned by the hot water and also by the steam, which one will be severe? Which one will be severe? You can show me. The first one is steam and the second one is hot water. Which one will be severe, please? Yes. Is that hot water? Is the burn by hot water severe than the steam?
most of them are going with steam.
All are going towards the steam.
No,
Definitely,
some
of them are like hot water. No, the burn by the steam will be more severe. So the burn by the steam will be more severe. Don't ever forget this. So this will be asked in the examination. Okay. So steam will be more hotter than the hot water. Steam will be more hotter. Why? Because they have the latent heat. Steam will be having the latent heat, right? They absorbed all the heat energy. Even though they have both 100 degrees Celsius, steam absorb the heat energy. That is latent heat. So the heat energy will be more in steam. So the burning by using the steam will be more severe than the hot water. Just keep this in mind always. Don't forget this. Okay. So, alright. Is that clear for you? Is everything clear for you? So which one will be more hotter? Steam or hot water? Definitely steam. Mehrab is like, no ma'am, it's not clear for me. So I'll discuss this again, okay? No worries, I'll discuss this topic again in the next section, okay? No worries. We'll discuss this again, okay? And you can clarify your doubts in the next session. I'm not going anywhere, okay? So conserve your doubts. So shall we do the exam then? It's already out of time. Alright, shall we do the exam? Okay, we'll discuss this topic again, okay? Don't worry. Okay, we'll go for the next exam. Exam.
Some of them done already.
Already done with the exam? Alright, I'll read the question meanwhile, okay? Which one has the least energetic molecule? Solid, liquid, gas and plasmas. Least energetic, they will not move around. They are least energetic. Kinetic energy will be less. And the second one, if you leave water in a glass and some molecules turns into gas, it is called condensation, evaporation, extinction or sublimation. The next one, SI unit of temperature is what? SI unit of temperature. And the boiling point of alcohol is 78 degrees Celsius. And what is the temperature in Kelvin scale? Don't guess it. Don't ever guess it, okay? Don't guess it. Please don't guess it. Do the calculation and do it. Do the calculation, okay? Do the calculation. So the next one, 0 degrees Celsius temperature is equal to what? Very simple, right? It was very simple. That's it. These are the 5 questions. We'll quickly discuss the questions and we will leave, okay? We'll quickly discuss the questions and leave. Okay, there's a butterfly flying around. Don't mind. Okay, the first, did everyone attended the exam? Is that done?
No.
It's not done yet. So we'll discuss the question in the next session. It will be
right, yeah.
It will be more good, right? Yes. Shall we discuss in the next session? Okay, we'll discuss this in the next session. Is that fine for you? So many of you haven't done with the exam yet, so we have to give them time. Ma'am, what is the first question answer? This one?
Then we need to answer.
Really need the answer for this? We'll discuss in the next class, okay? So many haven't done with the exam yet, so if I discuss the question, they will get 10 on 10. It will be cheating, right? No cheating. So we'll discuss that in the next session, like we did today. And thank you so much, okay? Thank you so much for listening to me. And I know you haven't understood the latent heat completely. No worries, we'll discuss that in the next session. And thank you so much for listening to me. And don't forget to do the homework. If you are coming without the homework, definitely I'm going to punish, okay? So study well and come back in the next class. Until then, take care. Bye-bye. Good night.